Hey everyone, welcome back for another deep dive. Today we're going to be tackling the world of large language models,
Oh, wow.
specifically a new series called Qwen 2.5.
Okay, interesting.
We're going to be breaking down a technical report published just yesterday, December 20th, 2024, by the team behind Qwen.
Okay.
Think of this as your cheat sheet to understanding this new AI development.
Yeah, I am excited to explore this. It looks like a pretty comprehensive report.
It really is. So, why are people buzzing about Qwen 2.5? One major reason is the sheer size of the data it's trained on, a massive 18 trillion tokens.
Wow, that's a lot.
To put that in perspective, that's a significant leap from its predecessor, Qwen 2, which used 7 trillion tokens.
Right.
The report suggests that this data scaling is a big reason why Qwen 2.5 shows such advanced skills in areas like coding, math, and knowledge-based tasks.
Yeah, that's an important point. The iterative nature of this development from Qwen 1.5 to Qwen 2 and now Qwen 2.5 really showcases how data scaling can lead to significant jumps in a model's abilities.
Right.
It's like giving the model a much larger library to learn from.
Yeah, and that's just one piece of the puzzle.
Right.
The report dives into two main categories of Qwen 2.5 models: dense models designed for open source use, and MOE, or mixture of experts, models intended for API services.
Interesting.
This two-pronged approach means they're catering to different user needs, whether it's transparency and accessibility or prioritizing performance.
It's a smart strategy to address diverse user needs.
Mm.
And speaking of the model's design, the report gets into the nitty-gritty of the architecture for both dense and MOE models. Right. Dense models utilize components like grouped query attention, or GQA, which helps with efficient memory use, as well as the SWIGLU activation function and other features like rotary positional embeddings and RMS norm.
Wow.
For those unfamiliar with those terms, they're basically tools that help the model learn and process information effectively.
It sounds like they've put a lot of thought into making the model as efficient as possible, considering the massive amount of data it's dealing with.
Right.
What's fascinating is how the MOE models build upon this architecture.
Uh-huh.
They incorporate specialized MOE layers, replacing standard layers to boost performance.
It's a bit like having a team of specialists, each with their own expertise ready to be called upon as needed.
Oh.
Now, beyond the architecture, the report delves into the meticulous pre-training process for Qwen 2.5.
Right.
This involves three key elements: data curation, hyperparameter optimization, and specialized training for handling long contexts.
That meticulous data curation really stands out in the report.
Yeah.
They talk about using Qwen to instruct models to carefully filter the data, ensuring they're only training on high-quality examples across multiple languages.
I see.
It's like having a team of editors scrutinizing every word before it goes into the model's training.
Right. They're really focused on quality over quantity.
Yeah.
They're not just throwing any data at the model. They're selecting the best possible example.
All right.
And they go a step further by integrating training data from specialized models like Qwen 2.5 Math and Qwen 2.5 Coder.
Okay.
This contributes to the model's state-of-the-art performance in those areas.
They're really catering to specific domains, like training a chef, by having them work with the best bakers and butchers, in addition to overall culinary techniques.
Right.
And it's not just about real-world data either. They even use Qwen 2 and Qwen 2 Math to generate synthetic data, especially in domains like math code and general knowledge.
The use of synthetic data is an interesting approach.
Yeah.
It allows them to augment existing data sets with custom-made examples, potentially filling gaps or addressing biases in the original data.
It's like creating custom training exercises for the model, giving it targeted practice in areas where it might need extra help.
Right.
Now, the report also highlights their focus on achieving a balanced beta mixture. They strategically downsample overrepresented domains like e-commerce and upsample those rich in information but often underrepresented, such as science and technology.
This approach ensures the model doesn't get an overly skewed perspective, preventing it from becoming a master of online shopping while neglecting crucial scientific concepts.
Yeah.
It's about providing a well-rounded education. Now, moving on from data, the report dives into the realm of scaling and hyperparameters.
This is where it can get a bit technical, right?
Yes, they discuss using scaling laws to figure out the optimal parameters for training both the dense and MOE models.
Yeah.
Essentially, scaling laws are mathematical relationships that help predict how a model's performance will change as you increase its size and the amount of data it's trained on.
So it's like a set of rules to help them navigate the training process more effectively, particularly as these models get larger and more complex.
Right.
What stood out to me is how they use these scaling laws to identify key training parameters, like batch size and learning rate, leading to a more efficient training process. It's like having a roadmap for the training journey.
It's essential to optimize the training process, especially when dealing with models of this scale. They even use these scaling laws to compare the performance of MoE models to dense models, making sure both types are configured optimally.
So they're really taking a data-driven approach to training, using these mathematical relationships to make informed decisions.
Right.
Now, the report then shifts gears to discuss long context training.
Yes.
Which focuses on Qwen2.5's ability to understand and process really long stretches of text.
Okay.
This goes beyond the usual limitations of most language models.
It's a significant development. Most language models have a limited window of attention, meaning they can only process a certain number of words or sentences at a time. But Qwen2.5 is designed to handle much longer sequences.
Interesting.
They achieve this through a two-phase pre-training approach.
Okay.
They begin with a context length of 4,096 tokens and then extend it to longer sequences.
Wow.
For most of the models, this culminates in a final context length of 32,768 tokens.
Wow, that's a massive leap.
It is.
It's like going from reading a tweet to processing an entire chapter of a book.
Right.
And for the Qwen2.5 Turbo model, they take it even further. They progressively increase the context length during training, ultimately reaching an incredible 262,144 tokens.
That's like reading a whole novel in one go.
Yeah.
They've truly pushed the boundaries of how much information these models can handle.
They don't stop there. The report explains how they use techniques like yarn and dual chunk attention, or DCA, to further extend the sequence length capacity during inference.
Wow.
This allows some Qwen2.5 models to process sequences up to 1 million tokens.
That's an incredible amount of data to process.
Yeah.
Think about the potential applications for analyzing huge documents or understanding long narratives.
Right.
These advancements in long context processing open up a whole new world of possibilities for what these models can achieve.
Now let's talk about post-training refinement.
Okay. This is where the model goes from like raw potential to practical application. They use techniques like supervised fine-tuning and reinforcement learning to really like shape the model's behavior and align it with desired outcomes.
It's like taking a talented but untrained musician and giving them rigorous instruction and practice to help them refine their skills and perform at a high level.
That's a good analogy. The report highlights two major advancements in Qwen2.5's post-training compared to its predecessor.
Okay.
They've expanded the supervised fine-tuning data and implemented a two-stage reinforcement learning process.
So they're not just making minor adjustments, they're really overhauling the training regimen to improve the model's capabilities. The report mentions using millions of high-quality examples for supervised fine-tuning, especially in areas where previous models like Qwen2 showed limitations.
Yeah, they're focusing on areas like long sequence generation, math problem solving, coding, structured data understanding, and logical reasoning. They're really targeting those weak points and making sure the model is well prepared for a variety of challenges.
It's impressive how they're addressing those limitations head on, and then they delve into this two-pronged approach to reinforcement learning.
Right.
Using both offline and online methods. What's the difference between those two?
So offline reinforcement learning focuses on developing complex capabilities that are difficult to evaluate using a standard reward model.
Okay.
It's like training for tasks that require more than just rote memorization.
Right.
They're looking at things like reasoning, factuality, and instruction following, where traditional evaluation metrics might not be sufficient.
So it's about going beyond just producing the correct answer and delving into the model's ability to think critically and solve problems in a more nuanced way. And what about online reinforcement learning? How does that differ?
Online reinforcement learning focuses on refining the output quality based on human preferences. It tackles those subtle aspects of communication, aiming to create a model that not only produces accurate results, but also communicates them in a clear, engaging, and effective manner.
It's like polishing a gem, refining those rough edges to make it truly shine. Now let's dive deeper into supervised fine-tuning.
Okay.
The report provides a detailed breakdown of how they've enhanced different aspects of the model's capabilities. One thing that jumped out at me is that Qwen2.5 can now generate content with an output length of up to 8,192 tokens.
Yeah.
That's a significant leap from previous limitations.
It is. This means the model can now handle much longer and more complex generation tasks. They achieved this by developing specialized long-response datasets and using back translation techniques to expand the model's generative abilities.
It's fascinating how they're using these techniques to push the boundaries of what the model can create. Another area where they've made significant improvements is mathematics. They incorporated data from Qwen 2.5 math, specifically using a technique called chain-of-thought prompting.
Right. Chain of thought prompting helps the model demonstrate its reasoning process. Instead of just giving the answer, it can show how it arrived at the solution step by step.
Yeah.
This transparency is helpful for understanding how the model solves problems and for verifying the accuracy of its calculations.
It's like having a math tutor that not only shows you the answer, but also walks you through the entire problem-solving process. The report also highlights their efforts to improve the model's coding skills by integrating data from Qwen 2.5 Coder. They cover nearly 40 programming languages and have implemented tools like a collaborative agent framework and a multilingual sandbox to ensure code quality and correctness.
Right. They're really taking a comprehensive approach to code generation, ensuring the model can not only write code in various languages, but also do so accurately and efficiently. They've even developed a rigorous code-based validation framework to ensure the model adheres to instructions faithfully.
It's reassuring to see that they're taking these measures to validate the code generated by the model. They've also enhanced the model's ability to work with structured data, like tables and JSON formats, by developing a comprehensive data set and incorporating reasoning chains.
Right. This expands the model's applicability to real-world scenarios where data is often presented in these formats. They've also focused on improving logical reasoning skills by introducing 70,000 new queries across various domains.
So they're training the model to think critically and apply different reasoning methods to solve problems. They're not just teaching it facts, they're teaching it how to think.
Yeah.
Another interesting aspect is cross-lingual transfer, where they focus on ensuring the model's capabilities translate well across different languages.
They use a translation model to convert instructions into various languages and evaluate the semantic alignment to ensure the translated responses maintain the intended meaning and style. They're really breaking down language barriers, making the model accessible to a wider audience.
It's exciting to see these advancements in multilingual capabilities. The report also mentions their efforts to make the model more robust to different system instructions, ensuring consistent performance regardless of how instructions are phrased.
Right. They've created hundreds of general system prompts to train the model to understand the intent behind instructions, making it less sensitive to variations in wording.
It's like teaching the model to understand the meaning behind the words, not just the words themselves. And finally, they discuss their multifaceted response filtering process, which uses automatic annotation, critic models, and multi-agent scoring systems to ensure the model's outputs meet high-quality standards.
They're really taking quality control seriously, implementing these checks and balances to ensure the model's responses are accurate, complete, and relevant. The report summarizes the supervised fine-tuning process, highlighting the massive scale of the data involved. Over 1 million examples, 2 epochs of training, and a sequence length of 32,768 tokens. These numbers are a testament to the effort and resources invested in fine-tuning this model.
It's clear they're committed to pushing the boundaries of what's possible with large language models. Now let's move on to the second stage of the reinforcement learning process, offline reinforcement learning.
As we mentioned earlier, this stage focuses on those capabilities that are more difficult to evaluate using traditional metrics.
Right.
They're targeting domains like math, coding, instruction following, and logical reasoning, where simple answer matching isn't enough.
So it's about pushing the model beyond just producing the right answer and into the realm of complex problem solving and critical thinking. The report explains how they utilize execution feedback and answer matching from earlier stages to ensure the quality of the responses during offline reinforcement learning.
They're essentially building upon the foundation laid in previous stages, using that information to further refine the model's capabilities. They also describe how they use the supervised fine-tuned model to resample responses for new queries.
That's interesting. It's like giving the model a new set of practice problems, testing its ability to apply its knowledge in different situations. And they make a distinction between positive and negative examples, feeding this information into the direct preference optimization or DPO training process.
This helps the model learn to distinguish between desirable and undesirable outcomes, further refining its decision-making process.
And they emphasize that they use both human and automated review processes to ensure the reliability of the training signals. It's like having a team of experts, both human and artificial, working together to guide the model's development. The report provides a concise summary of the offline RL process, 150,000 training pairs, 1 epoch of training, and specific details about the optimizer and learning rate used. It's fascinating to see the scale and complexity of this training process.
It really highlights the level of detail and rigor involved in developing these models. Now let's shift gears and talk about online reinforcement learning.
This is where we get into those finer points of communication, right? Shaping the model's output to align with human preferences.
Online reinforcement learning focuses on those aspects of communication that go beyond simple accuracy.
Okay.
Things like truthfulness, helpfulness, conciseness, relevance, harmlessness, and debiasing. They want to create a model that not only provides correct information, but also communicates it effectively and ethically.
So it's about teaching the model to be a good communicator, not just a repository of facts. The report provides a breakdown of those 6 key criteria used to train the reward model. Those criteria serve as guidelines for human annotators, ensuring that the training data reflects those desired qualities.
They're essentially setting up a code of conduct for the model, guiding it toward a communication that aligns with human values and expectations.
The report also describes the diverse sources of queries they use to train the reward model,
Right.
including both publicly available data and a proprietary query set.
This diverse range of queries ensures that the reward model can generalize well to various situations and user requests. They're exposing the model to different perspectives and communication styles, helping it develop a nuanced understanding of human communication.
And they introduce even further diversity by generating responses from different Qwen model checkpoints sampled at different temperature settings.
What are those temperature settings? The temperature setting essentially controls the randomness of the model's output. A higher temperature will produce more diverse and unpredictable responses, while a lower temperature will result in more deterministic and focused responses.
Okay.
By sampling responses at different temperatures, they can create a richer and more varied data set for training the reward model.
It's like showing the model different ways of expressing the same idea, helping it develop a more flexible and adaptable communication style.
They use both human and automated labeling processes to create preference pairs for training the reward model, giving it a comprehensive understanding of human preferences.
It's a collaborative effort combining human insight with the efficiency of automated processes. The report then goes into detail about the reinforcement learning algorithm they use for this stage group relative policy optimization, or GRPO.
Right.
They explain how they prioritize queries based on the variance of their response scores.
This prioritization strategy ensures that the model focuses on the most challenging cases, those where there's greater uncertainty or disagreement about the best response. It's like a teacher focusing on the students who need the most help.
They provide specific details about the training setup. 8 responses sampled per query, a global batch size of 2048 and 2048 samples per episode. These technical details highlight the complexity and scale of this training process. Now let's talk about the long context fine-tuning process, specifically for the Qwen2.5 model.
Okay, remember, this is the model designed to handle those incredibly long sequences of text, up to 1 million tokens. The goal here is to further refine the model's ability to work with extended contexts.
It's like training an athlete to run a marathon after they've already mastered shorter distances. They describe this 2-stage approach in the supervised fine-tuning phase. First, they fine-tune the model with short instructions up to 32,768 tokens.
Right.
This ensures it maintains its performance on shorter tasks.
They're making sure the model doesn't lose its ability to handle those quick sprints while training for the marathon. And then in the second stage, they combine both short and long instructions, expanding the model's capabilities up to 262,144 tokens.
So they're gradually stretching the model's limits, training it to handle both short bursts and extended streams of information. The report mentions that during the reinforcement learning stage, they focus solely on short instructions for Qwen2.5 Turbo.
This is mainly due to the computational costs and the lack of suitable reward models for evaluating performance on long context tasks.
It makes sense to prioritize efficiency in this stage. They reassure us that this focused approach still enhances the model's alignment with human preferences, even for those long context tasks. Now let's transition to the evaluation phase.
Okay.
This is where they put Qwen2.5 through a rigorous series of tests to assess its performance across a variety of tasks and benchmarks.
It's like the AI Olympics, where they get to see how Qwen2.5 stacks up against other state-of-the-art models.
The report emphasizes their efforts to ensure the integrity of the evaluation process. They take steps to prevent data leakage and maintain a level playing field. They use techniques like n-gram matching to exclude potentially contaminated data from the training and evaluation sets.
Right. They're making sure the AI isn't cheating by seeing similar data during training and testing. It's like ensuring that students haven't seen the exam questions beforehand.
They begin by evaluating the base models, focusing on areas like natural language understanding, question answering, coding, math, scientific knowledge reasoning, and multilingual capabilities.
Right. They really put those foundational models through the ringer, testing their knowledge comprehension and problem-solving skills.
And they don't just rely on one or two tests. They use a comprehensive suite of open benchmarks, each designed to assess specific capabilities.
It's like an academic decathlon for AI with different events testing different skills.
They compare the performance of Qwen 2.5 to previous Qwen models, as well as other leading open-weight models, to provide a point of reference and see how much progress has been made.
One of the key findings is that the Qwen 2.5-72B base model outperforms its peers in the same size category across a wide range of tasks.
So it's not just keeping up with the competition. It's setting a new standard for performance in that size category. And not only does it outperform other models of similar size, it even achieves results comparable to the much larger Llama 3 405B model.
That's a significant achievement, demonstrating the efficiency of Qwen 2.5. It can deliver high performance without requiring the massive resources of a much larger model.
They're really achieving more with less, which is always a good thing in the world of AI. And they're not just comparing against other models, they're also looking at how Qwen 2.5 improves upon its own predecessors. The report highlights significant improvements in general tasks, mathematics, and coding compared to the previous Qwen 2.72B model.
It's a testament to the iterative development process. They're constantly refining the model, building upon previous successes, and addressing limitations.
Now, they also evaluated the Qwen2.5-Turbo model, which is a MoE model designed for API services. They compared it to other models of similar size, including the Y1.534B and Qwen2.5-B models.
And despite having smaller training and inference costs, Qwen 2.5-Turbo delivers comparable results, even outperforming the Qwen 2.532B model on some tasks.
It's another example of Qwen 2.5's efficiency. They're achieving impressive performance without requiring excessive resources.
Right. They also evaluated the Qwen 2.5-14B and 32B models against others, like the Y1.534B and Qwen2.5-B models.
These mid-size models are often a sweet spot for many applications, balancing performance with resource requirements.
The Qwen 2.5-14B excels in general tasks, and the Qwen 2.532B demonstrates exceptional capabilities, surpassing larger models in math and coding. It's like they found the Goldilocks zone for AI, where the model size is just right for the task at hand.
And they didn't stop there. They also compared the Qwen 2.5-7B model to other 7B plus models, like the Mistral 7B, Llama 3 8B, and Qwen2.5 models.
This size category is becoming increasingly popular as it offers a good balance of capability and accessibility.
And despite having fewer non-embedding parameters, the Qwen 2.57B model outperforms those other models, showcasing significant improvements across various tasks. It's another demonstration of Qwen 2.5's efficiency and performance. They even evaluated the smallest Qwen 2.5 models, the 0.5B, 1.5B, and 3B versions, against models like the Qwen 2.5B, 1.5B, and Qwen2.6B models.
Right. These smaller models are crucial for applications that require low resource consumption, like those running on edge devices.
And despite their small size, these models continue to perform well, demonstrating their suitability for a variety of applications. It's like having a pocket-sized AI that can still handle demanding tasks.
The overall takeaway from the base model evaluations is that the Qwen 2.5 series demonstrates impressive capabilities across different model sizes, often outperforming competing models. They've laid a solid foundation for building even more powerful and versatile instruction-tuned models.
Speaking of which, let's discuss the evaluation of those instruction-tuned models.
Okay, this is where they really focus on aligning the models with human expectations and preferences. It's not just about producing any output, it's about producing the right output, the output that a human would find helpful and relevant.
They want to ensure that the AI understands our nuances and responds in a way that we find natural and engaging.
Right. They use a multifaceted approach combining open benchmarks, in-house evaluations, and a focus on long context capabilities.
So they're testing the model's ability to follow instructions, generate creative text formats, understand complex concepts, and handle those very long stretches of text.
They started with open benchmarks, providing a standardized way to compare different models.
It's like having a universal scoring system, allowing them to compare apples to apples. These benchmarks, like MLU Pro, MMLU Redux, and LiveBench 0831 for general evaluation,
Right.
GPQA, GSMAK, and Math for science and mathematics, Human Evil, MBPP, MultiPLE, and LiveCodeBench 2305, 2409 for coding, and IFEVL for instruction following.
These benchmarks cover a wide range of skills and knowledge areas, providing a comprehensive assessment of the model's capabilities.
And they also used benchmarks like MTBench and ArenaHard to assess those more subjective aspects of AI, like how well the models understand human nuances and preferences.
Right. They're looking at how well the models can align with human expectations in those more subjective tasks. And the results are very promising. The Qwen2.5 7.2b Instruct model delivers exceptional performance, even surpassing the larger Llama 3.1 405b Instruct model on several benchmarks.
Another example of Qwen 2.5 punching above its weight class, demonstrating the effectiveness of their training methods.
Okay.
And it's not just the 72B model. The Qwen 2.5-Plus model also exhibits strong performance, highlighting the benefits of the MOE architecture for these instruction-tuned models.
It really showcases the flexibility and scalability of the MOE approach.
And those smaller Qwen 2.5 instruct models, the 14B and 32B versions, also deliver competitive results, demonstrating their cost-effectiveness.
Right, they're striking that balance between performance and resource requirements.
And the Qwen 2.57B Instruct model performs exceptionally well, particularly in math and coding tasks.
It showcases the versatility of the model, its ability to handle both logical and creative challenges.
Now, beyond those open benchmarks, they also conducted in-house evaluations, going deeper into the model's capabilities.
Right. They developed their own datasets, focusing on areas like knowledge understanding, text generation coding, and multilingual performance.
It's like creating a custom-designed test tailored to their specific research goals.
They compare the Qwen 2.5 Instruct models to other leading models, including GPT-4, Claude 3.5 Sonnet, Qwen2, and Llama 3.1, across both English and Chinese. It's a global showdown, testing the AI's abilities across different languages and cultures.
And what did those in-house evaluations reveal?
One interesting observation is that the smaller Qwen 2.5 models often perform on par with or even exceed larger models from the previous generation.
That suggests they've done a great job optimizing parameter usage, getting the most out of those resources.
Right. And the Qwen 2.5-72b model narrows the gap between Qwen and state-of-the-art models like GPT-4 and Claude 3.5 Sonnet. It matches or exceeds the performance of Llama 3.1 405b in all metrics except instruction following.
They're really closing in on the performance of those industry giants.
The Qwen 2.5-Plus model improves upon previous shortcomings in Chinese instruction, following further solidifying its advantages.
They're constantly learning and refining, addressing those areas where the models can improve.
And across the board, the Qwen 2.5 series exhibits competitive multilingual performance, particularly in instruction following knowledge utilization and mathematical reasoning.
They're developing a global AI that's fluent in multiple languages and capable of handling a diverse range of tasks. Now, they also spend time in the report evaluating the reward model, which is so crucial for shaping the AI's behavior during reinforcement learning.
It's like the model's conscience guiding it toward ethical and effective communication. They use several benchmarks to assess the reward model's effectiveness, including Reward Bench, RMB, PPE, and their own internal Chinese human preference benchmark.
They're testing the reward model's ability to align with human values and preferences across different languages and cultures.
Right. They compared the Qwen 2.5 reward model to other leading models, like Nemotron 4 340B reward, Llama 3.1 Nemotron 70B reward, and Athena RM 70B. It's a head-to-head competition between those AI consciences to see which one best reflects human values.
What were the results of that comparison?
The results show that different reward models have strengths in different areas, highlighting the need for diverse evaluation metrics. It's like having different judges for an Olympic event, each with their own expertise and perspective.
Now, there's no single best reward model, but rather different models that excel in specific areas. The Qwen 2.5 reward model demonstrates strong performance across multiple evaluations, indicating its effectiveness in capturing human preferences.
It's a well-rounded reward model, capable of guiding the AI toward ethical and effective communication. However, the report points out a crucial observation about reward model evaluation. Over-optimizing for a specific benchmark can negatively impact performance on other benchmarks.
It's a reminder that we need to be careful about how we train these models, and that focusing too narrowly on a single metric can have unintended consequences.
They also highlight that current benchmarks might not accurately predict the performance of the resulting models, underscoring the need for further research in this area.
Now let's shift focus to the evaluation of Qwen 2.5's long context capabilities, those marathon reading sessions we talked about earlier.
Right. They used benchmarks like Ruler, LV-Eval, and Long Bench Chat to assess those abilities. These benchmarks test the AI's ability to retain information, make connections, and generate coherent responses when dealing with very long texts. It's like testing the AI's long-term memory and its ability to synthesize information from a lengthy document.
And how did Qwen 2.5 perform on those long context benchmarks?
The Qwen 2.5 models, especially those enhanced with length extrapolation techniques like DCA and yarn, performed remarkably well.
They really exceeded expectations, demonstrating their ability to process those extensive texts without losing track of the information.
Mm-hmm. The Qwen 2.5 72B instruct model in particular stands out. It outperforms other open-weight long context models and even surpasses proprietary models like GPT-4o-mini and GPT-4 in some cases.
That's a testament to the effectiveness of their training methods and the potential of open-weight models to achieve state-of-the-art performance.
And remember that Qwen 2.5 Turbo model. It achieved 100% accuracy in a 1 million token Pascal retrieval task. It's like having an AI detective that can sift through a mountain of data and pinpoint the crucial piece of evidence.
That's an incredible demonstration of its ability to handle those ultra-long contexts. Now, being able to process those long contexts is one thing, but doing it efficiently is crucial for practical applications. The report highlights their use of a sparse attention mechanism to speed up inference, making the model much faster when dealing with those large chunks of text.
This is a crucial aspect for user experience. Nobody wants to wait forever for the model to process a long document. They found that this approach leads to a significant speedup between 3.2 and 4.3 times faster in some cases.
It's like going from a horse-drawn carriage to a high-speed train, a dramatic improvement in efficiency. Those are some impressive results. Overall, the evaluation section paints a very positive picture of Qwen 2.5's capabilities.
It's a powerful and versatile series of models demonstrating significant advancements in coding, math, instruction following, and long context processing. They've really pushed the boundaries of what's possible with open-weight models delivering high performance and efficiency.
And throughout the report, they emphasize the importance of rigorous and ethical evaluation, ensuring that the reported performance is an accurate reflection of the model's true capabilities.
Yeah.
It's a reminder that AI development isn't just about building bigger and more complex models, but also about carefully evaluating those models and making sure they align with human values.
Right. It's been a pleasure exploring these advancements with you.
It's been a pleasure diving into this technical report with you. Until next time.
They've done a really thorough job testing these models and making sure they're not just impressive in a lab setting, but also capable of handling real-world tasks responsibly and effectively.
Yeah, they've highlighted that throughout the entire report.
Right now, before we wrap up, I wanted to circle back to something we touched on earlier.
Okay.
Qwen 2.5's ability to handle those long contexts.
Right.
The report really emphasizes this aspect, and for good reason.
Yeah, it's one of the most exciting things about this new model, the ability to process and understand those extended sequences of text. This opens up a whole new realm of possibilities for how these models can be used.
Like you said, it's a game changer. They really put those long context capabilities to the test using benchmarks like Ruler, LV-eval, and Long Bench Chat. These benchmarks challenge the AI to retain information, make connections, and generate coherent responses even when dealing with a massive amount of text.
It's like testing the model's ability to read and comprehend an entire book, remembering those crucial details and drawing connections between different parts of the story.
Exactly. And the results of these tests are quite impressive. The Qwen 2.5 models, particularly those that incorporate length extrapolation techniques like DCA and yarn, demonstrate exceptional long context handling.
Yeah, they're not just skimming the surface. They're really diving deep into those long texts and demonstrating a solid understanding of the information.
The Qwen 2.5 72B instruct model in particular stands out. It outperforms other open-weight long context models and even surpasses proprietary models like GPT-4o-mini and GPT-4 in some cases.
Wow, so they're really competing with the big leagues now.
They are. It's a remarkable achievement showing that open-weight models can compete at the highest level even in these challenging long context tasks.
And I think it was in part 2, we talked about the Qwen2.5 Turbo model designed for API services.
Right.
And it achieved 100% accuracy in a 1 million token Pascal retrieval task.
Yeah, that's incredible.
That's an incredible feat, demonstrating the ability to pinpoint a specific piece of information within a truly massive text.
Like finding a needle in a haystack.
Yeah, but the haystack is 1 million words long.
Right.
Now, being able to process those long contexts is one thing, but doing it efficiently is crucial for practical applications. The report highlights their use of a sparse attention mechanism to speed up inference, making the model much faster when dealing with those large chunks of text.
Right. This is a crucial aspect for user experience. Nobody wants to wait forever for the model to process a long document.
Exactly.
They found that this approach leads to a significant speedup between 3.2 and 4.3 times faster in some cases.
Yeah, that's a huge improvement. It's like going from a horse-drawn carriage to a high-speed train.
Right, a dramatic improvement in efficiency.
So overall, it seems like we've reached the end of our deep dive into the Qwen 2.5 technical report.
Yeah.
We've covered a lot of ground today, from the model's architecture and training methods to its impressive performance on a wide range of benchmarks.
It's been a fascinating exploration. Qwen 2.5 represents a significant step forward in the development of large language models, showcasing the potential of open-weight models to achieve state-of-the-art results in areas like coding, math, instruction following, and of course, long context processing.
The team behind Qwen 2.5 has clearly put a lot of thought and effort into designing and evaluating these models, pushing the boundaries of what's possible with AI. They've also emphasized the importance of responsible AI development, using rigorous evaluation methods to ensure the model's capabilities are accurately represented and align with human values. It's been a pleasure diving into this technical report with you.
Likewise, I always enjoy these conversations.
Until next time.
Take care.